Ready for another deep dive? Today, we are heading straight to the center of our solar system. We're talking about the sun.
Oh, yeah, the sun.
We've got a ton of fascinating excerpts
Really cool stuff.
about the sun, and I really want to kind of sift through them and figure out what's going on with this star that honestly makes life on Earth possible.
Yeah, it's amazing how often we kind of take the sun for granted.
Right.
I mean, it's just there,
Yeah.
right?
Yeah.
But when you really start thinking about it and digging into it, it's just this incredibly complex and powerful object.
Okay, so let's unpack this a little bit.
Okay,
Our sources jump right into talking about the structure of the sun,
right?
and specifically the sun's core,
Yeah.
which is, essentially it's a giant nuclear reactor in space,
It is.
turning away at these just unimaginable temperatures and pressures.
Yeah, millions and millions of degrees and incredible pressure.
It's hard to even fathom. So
Yeah.
in the core, that's where hydrogen atoms are being fused together
Yes,
to create
yes.
helium. And in that process, an incredible amount of energy is released.
It is. I mean, we're talking the equivalent of millions of hydrogen bombs exploding every second.
Whoa, hold on. Millions of hydrogen bombs every second.
Every second.
That's a lot.
That's a lot of energy.
So this fusion process,
Yeah.
that's what keeps the sun burning.
That is what keeps the sun burning.
Okay.
They call it the proton chain reaction.
Okay.
And basically, it's a three-step process where you have hydrogen nuclei slamming together and they fuse and they release energy. And then there's some other particles involved. But the main takeaway is that a tiny bit of mass is converted into a tremendous amount of energy.
Okay, so more than just fire, it's like E equals MC squared in action,
Exactly.
converting matter into energy.
Yes,
That's wild.
it is.
So that would mean, though, that the sun is constantly losing mass.
It is constantly losing mass, but it has so much mass
Yeah.
that it can keep this up for billions of years.
Okay.
Our sources also mention another fusion process that happens in hotter stars. Yeah, the CNO cycle, which uses carbon, nitrogen, and oxygen as catalysts.
Interesting.
Yeah.
So we've got this crazy amount of energy being generated in the sun's core.
Yeah.
Where does it go from there?
Well, it doesn't take a direct route.
Okay.
It actually travels through two more layers before it escapes the sun's interior.
Okay.
The first one is the radiative zone, and the energy here travels primarily through radiation.
Okay.
So think of it like photons
Okay.
bouncing around for thousands of years
Thousands of years.
just to get through this layer.
Wow, it's a long commute.
It is a long commute. But finally, those photons reach the convective zone, which is the outermost layer of the sun's interior.
Okay.
And here it's a bit cooler. And the plasma, which is essentially superheated gas, can move around more freely.
So it's almost like the plasma is boiling?
Exactly. Think about a pot of water on the stove.
Okay, yeah.
The hot water rises, cools, and sinks back down, creating those circular currents. And it's the same principle in the sun, just on a much, much larger scale.
Mhm.
And these currents create those granulation patterns we see on the sun's surface.
Oh, okay.
It looks kind of like a bubbling cauldron.
It's interesting how these processes like convection happen not just in the sun, but also in our everyday lives.
Right.
I mean, that's what drives our weather patterns here on Earth, too.
Absolutely.
So the sun's energy is finally reaching the surface.
Yes.
Where does it go from there?
Well, once it reaches the surface, it radiates out into space as sunlight, and some of it eventually reaches us here on Earth.
Mm.
But before we get to that, we have to talk about the sun's atmosphere.
Okay.
There's a lot happening out there.
Okay. Lead the way.
The sun's atmosphere is made up of several layers.
Okay.
We've got the photosphere, the chromosphere, and the corona, each with its own unique characteristics and mind-blowing phenomena.
Okay. That's a lot of eye spheres to keep track of.
It is.
Let's start with the photosphere.
Okay.
What's going on in that layer?
The photosphere is what we see.
Okay.
It's the visible surface of the sun,
Okay.
and that's where all the sunlight originates. Now, you might be surprised to learn that compared to the core, the photosphere is actually quite cool.
Cool.
Yeah.
I mean, how cool are we talking? Because I'm pretty sure it's still way too hot to hang out there.
Oh, yeah. It's definitely too hot.
Yeah.
The photosphere has a temperature of around 5,500 degrees Celsius.
Okay.
So compared to millions of degrees in the core, that's practically a cool breeze.
Yeah, I guess in comparison.
Right. And that's where we see some interesting features like sunspots.
Well, sunspots, those are the dark patches on the sun's surface, right?
Oh, yeah.
What are those exactly?
They're actually cooler regions on the photosphere
Oh,
caused by intense magnetic activity.
okay.
These sunspots can last for days, even months, and some of them can grow larger than the Earth.
Wow.
Yeah,
And I've heard that sunspots can actually impact us here on Earth.
they can.
Is that true?
They're indicators of increased solar activity, which can lead to some pretty powerful events like solar flares and coronal mass ejections, which can impact our technology and even cause disruptions.
Wow. So even though they just seem like these dark spots, they're actually signs of some pretty wild stuff happening on the sun.
Exactly.
Wow. Okay.
But let's continue our journey outwards to the next layer up the chromosphere.
Okay.
This layer sits just above the photosphere, and it's actually hotter,
Okay.
with temperatures ranging from 4,000 to 20,000 degrees Celsius.
Wait a minute. So it gets hotter the further away you get from the core?
It does. It's actually one of the biggest mysteries in solar physics.
Really?
Yeah, scientists are still trying to figure out exactly why the corona, the outermost layer,
Yeah.
is so much hotter than the surface.
Huh.
But that's a story for later. For now, let's stick with the chromosphere.
Okay.
And this layer is where we see some of the most dramatic features of the sun's spicules and prominences.
Okay. Paint me a picture. What do those look like?
Okay, imagine jets of hot plasma shooting out from the sun's surface at incredible speeds.
Okay.
Those are spicules.
Okay.
And prominences are these massive loops of plasma
Wow.
extending thousands of kilometers into space, almost like fiery arches.
Wow. I'm starting to wish we had booked a seat on a space telescope for this deep dive.
Right.
It's pretty incredible.
Yeah, so for now, let's just continue our journey outwards to the final layer of the sun's atmosphere,
Okay.
the corona.
Okay.
This is the outermost layer, extending millions of kilometers into space.
Okay.
And this is where things get really interesting and hot.
Okay.
Temperatures in the corona can reach up to 3 million degrees Celsius.
3 million degrees.
3 million degrees.
Wow. I don't even have words.
It's mind-boggling. And this incredible heat is part of what makes the corona so mysterious.
Yeah.
Scientists are still trying to figure out how it gets so hot.
Huh.
But it's from the corona that the solar wind originates this constant stream of charged particles flowing out from the sun and influencing the entire solar system.
The solar wind. I remember reading about that. Doesn't it interact with Earth's magnetic field?
It does, and that interaction is what creates those stunning auroras, the northern and southern lights.
Oh, wow.
But the solar wind can also have some less pleasant effects.
Okay.
It can disrupt satellites and even cause power outages here on Earth.
So it's kind of like a double-edged sword.
Mm.
Beautiful light shows, but also the potential for some trouble.
Yeah, that's a good way to put it. But let's delve deeper into the world of solar activity
Okay.
and explore how those sunspots we talked about play a role in shaping space weather.
Okay.
That's where things get really interesting.
All right, let's do it.
Okay.
So we were talking about sunspots being indicators of like increased solar activity.
Yeah.
What else is going on out there?
So those sunspots are regions of intense magnetic activity,
Right.
and all that pent-up energy needs an outlet.
Okay.
And sometimes it gets released in these sudden, powerful bursts,
Okay.
solar flares, and coronal mass ejections.
Solar flares.
Yeah.
Those sound pretty intense.
They are.
What exactly happens during a solar flare?
So imagine this massive explosion on the sun's surface, this blinding flash of light and radiation.
Okay.
That's a solar flare. We're talking energy equivalent to millions of hydrogen bombs going off at the same time.
Okay. I'm officially terrified.
Yeah, they're powerful.
Do those flares reach Earth?
So the light from a flare reaches Earth in about 8 minutes.
Wow.
But the real concern is the radiation and charged particles that are blasted out.
Okay.
Those can interfere with radio communications, disrupt GPS, and even damage satellites.
So that's what keeps those space weather forecasters up at night.
Absolutely. Predicting and tracking solar flares is a crucial part of their job.
Wow.
And then there are coronal mass ejections, or CMEs for short.
CMEs.
Yeah.
What are those like?
Picture a giant bubble of superheated gas laced with magnetic fields being hurled out from the sun's corona.
Okay.
That's a CME.
Wow.
And unlike flares, which are mainly radiation,
Right.
CMEs throw huge amounts of matter into space,
Right.
traveling at millions of kilometers per hour.
Millions of kilometers an hour. That's incredible.
It's fast.
If one of those hit Earth, it would be like a cosmic bulldozer.
Yet you're not wrong. When a CME slams into Earth's magnetic field, it triggers a geomagnetic storm.
Geomagnetic storm.
Yeah.
That's scary.
They can be on the plus side. Geomagnetic storms cause those incredible auroras.
Oh.
But on the less fun side,
Yeah.
they can mess with power grids, radio communications, GPS, and even pose a radiation risk to astronauts.
Oh, wow. So it's like a solar tsunami.
Yeah.
Causing all kinds of havoc when it hits.
Very good analogy. And
Yeah.
just like with tsunamis predicting and preparing for CMEs is key.
Yeah, for
But
sure.
even when there aren't any major solar storms, there's still the solar wind constantly blowing out from the sun.
Right, the solar wind, the one
Uh-huh.
that creates the gorgeous auroras.
That's the one, but it's more than just a light show. The solar wind is constantly shaping the space environment around Earth, influencing our planet's magnetic field and even our atmosphere.
So it's like a constant invisible force
Yeah,
shaping our world, even though the sun is millions of kilometers away, we're still feeling its effects.
precisely. And to really understand those effects, we need to trace the journey of the sun's energy all the way to Earth.
Okay, so it all starts with that nuclear fusion back in the core, right?
All that energy from hydrogen fusing into helium needs a way to escape the sun.
Right.
First, it travels through the radiative zone, where photons bounce around for thousands of years.
Okay, we covered that.
And then it's onto the convective zone with that boiling plasma we talked about.
Yeah. How does that energy finally break free from the sun and get to us?
So once the energy gets to the photosphere, the sun's surface, it radiates out as sunlight.
Sunlight, of course, that's the key. How long does it take for sunlight to travel from the sun to Earth?
About 8 minutes.
8 minutes. So the sunlight we're seeing right now is actually 8 minutes old.
Exactly.
Wow, that's amazing. And that sunlight, it's more than just light, right?
Right.
It carries energy that drives our climate, our weather patterns, and ultimately makes life on Earth possible.
It is that sunlight powers photosynthesis, which is how plants convert light into energy. That's the basis of almost every ecosystem on our planet.
Wow, it's incredible to think that everything we see around us, all life on Earth, is ultimately powered by these nuclear reactions happening millions of kilometers away.
It's a powerful reminder of how interconnected everything is in our solar system.
Mm.
The sun's energy isn't just something we observe, it's something we directly experience and rely on.
Yeah.
Makes you appreciate that big ball of fire in the sky a little more, doesn't it?
So we've covered a lot of ground in this deep dive into the sun.
Yeah.
From the nuclear furnace at its core
Right.
to the solar wind that shapes the space around us.
Yeah, it's been quite a journey.
It really has. What's been like the biggest aha moment for you in all this?
For me, it's the amazing contrast within the sun itself.
Okay.
You have this incredibly dense, hot core
Yeah.
where matter is literally being transformed.
Right.
And then you have these much more subtle processes
Yeah.
like radiation and convection,
Right.
slowly transporting that energy outwards.
It's like this cosmic balancing act.
It is.
Immense power and these delicate processes all working together.
Yeah. And then you have the enigma of the corona,
Right.
millions of degrees hotter than the surface.
It's wild.
It still boggles my mind.
It's a reminder that we still have so much to learn
We do?
about our own star.
Absolutely.
And it's those unsolved mysteries that drive scientific curiosity
They do.
and push us to explore further.
Absolutely.
And speaking of exploration,
Yeah.
we can't forget about the sun's impact on Earth.
Right.
It's not just a source of warmth and light,
Right.
but it's a force that can disrupt our technology and even pose a threat to astronauts.
Very true. Those solar flares and coronal mass ejections,
Yeah.
those are events we need to understand and predict
Yeah.
if we want to protect ourselves.
So studying the sun isn't just about satisfying our curiosity, it's
Yeah.
about safeguarding our technological world.
It really is.
After this deep dive, I'm seeing the sun in a whole new light. It's not just a bright object in the sky.
Yeah.
It's a dynamic, powerful force that shapes our world for better or for worse.
It is the heart of our solar system,
Wow.
a source of energy, life, and even potential danger.
It's pretty incredible.
As we continue to unravel its secrets, I'm sure we'll find even more wonders.
I think you're right. Well, you've given us so much to think about.
It's been fun.
From the mind-boggling scale of nuclear fusion
Yeah.
to this intricate dance between the sun and Earth.
A lot going on.
Really is, it makes you wonder what other secrets the universe holds,
I know.
just waiting to be discovered.
So much out there.
How will our understanding of the sun continue to evolve as we explore?
Yeah, who knows what we'll find.
Thanks for joining us on this incredible journey to the heart of our solar system.